So for section 1.1, and I'm going to go ahead and, just kind of go through this, but I'm going to encourage you guys, I'll have this posted on the class site. When you get logged in, it'll say lecture videos, and you can access this there. So I'm going to go through this, but please feel free, feel free to just, apparently it's not going to work for me. There we go. Feel free to pause this because there's going to be some times where you need a little more time to write it down. If that happens today, feel free to ask the teacher to pause it and copy it down. And again, if you have any questions, this should be enough to get you at least started on the homework. So come back with questions, and I'm going to post other lecture videos by the end of class today. They should have the other ones posted, so you should be able to continue to work ahead. Anyway. Okay, so when we have an exponent, these are our topics: exponents, order of operations, and inequalities. That's our first section. That's something like 3 to the 4th power, right? When we say 3 to the 4th power, I'm gonna take it a little further and say, well, what does it mean? Well, it means 3 times 3 times 3 times 4 times, right? So we have two parts to 3 to the 4th power. We have the base, that is this lower number, and that is the number we are multiplying by. So in this situation, we are multiplying by 3. And then we have the exponent. The exponent is that kind of smaller number on the top, right? And that exponent is not what we're multiplying by. It's the number of times we multiply by the base. So when I say 3 to the 4th power, we are multiplying by the base, 3, 4 times. 3 times 3 times 3 times 3. And then we could evaluate that. We could kind of go from left to right. 3 times 3 is 9. Times 3 is 27. 27 times 3 gives us 81. That's one option. Or I could actually multiply the first two 3's and get a 9, times the second two 3's and get a 9, and get 81. But either way, 3 to the 4th power is not 12, right? It's not 3 times 4. It's 3 times itself 4 times. So that's kind of the basic idea of what an exponent is. And I know that seems basic now, but that's going to be really important as we continue working on that through the variables. So, b is the base, number we multiply by, the e right there is the exponent, the number of times we multiply by. So a lot of times I'll write this as, b base to the e exponent. Okay? All right. Let's evaluate these. 5 squared. Keep in mind when I say evaluate these, this first test we are not going to be using a calculator. This is the only test that I want to verify that you can do the computations by hand. So when I say 5 squared, you need to go in there and go, okay, that means the base, 5, times itself twice. Does not mean 10. We already have something that means 5 times 2. It's 5 times 2. 5 to the 2nd power means 5 squared, or 5 times 5. Hopefully we got 25 on that. Okay. If I have 6 to the 3rd power, we're looking at 6 is the base. So we're multiplying by 6. How many times? 3 times. Base 3 times. 6 times 6, 36. 36 times 6. I'm going to be asking you to do some computations like this. So you may have to be taking some of this math and going to the side. 6 times 6, 36. Carry that 3. 6 times 3, 18 plus the 3, 21. So our final answer for this would be 216. What about 2/3 to the 3rd? What's the base there? Well, we're multiplying by 2/3 3 times. This is an important time to note. How do we multiply fractions? Straight across. That's a G. There we go. Across. So if I had something like 1/2 times 1/3, the 1 and the 1 would multiply to make a 1 on the top. The 2 and the 3 would multiply to give a 6 on the bottom. Just straight across. So when I'm multiplying this, we're literally just multiplying the top across. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Multiply those straight across. 3 times 3 is 9. 9 times 3 is... Hopefully I'm not the only one that knew that was 27, right? You're supposed to kind of respond to that. That's okay. So yeah, you just need to multiply those straight across. And yeah, I will be asking you to do this without a calculator. That also means I could ask something like 0.3 squared. You do need to remember the rules of decimals. So 0.3 squared means 0.3 times 0.3. You need to take that to the side. How do we multiply these? Well, I do just 3 times 3 is 9. 9 times 0 is 0. I could multiply by the 0, it won't change anything. So I know that it's going to be a 9 and a 0. Sorry about that. I need to close my emails. But then you need to remember, how do we move the decimal, right? Well, you see how many numbers are past the decimal. This 3 is past the decimal, this 3 is past the decimal. So there are 2 numbers in total past the decimal. So what that does is it takes the decimal and moves it twice to the left. So 0.09 or 0.09. Now we're going to talk about topic 2, which is the order of operations. Keep in mind, I know people know PEMDAS. I was not fortunate enough to get that, but write this down while I'm talking, first of all. But I didn't have PEMDAS. We just did order of operations, and we're expected to just have them memorized. And it wasn't until I got to teaching that somebody was like, "Oh, you know, PEMDAS," or "Please excuse my dear Aunt Sally," and I was like, "That's great." I mean, I'm not afraid of tricks, that help you remember things that are kind of complicated. That's okay. But you do need to keep in mind, if you do PEMDAS, or if, when you're doing order of operations, there are 4 different steps here. A lot of people go, "Well, you just said 6 letters." I know. But P, we know, is the parentheses. Parentheses are basically grouping. So P is the grouping of the parentheses. E is the exponents. But our 3rd step is not multiply and then our 4th step divide. Our 3rd step is multiply and divide. See, those 2 operations are actually connected mathematically. And so when we do order of operations, those both occur at the same time, specifically from left to right. So we read an equation like we read a book. It's convenient. We, in this culture, read left to right. When we do mathematics, we also read it from left to right. So that order kind of tells us what to do it. I still wouldn't do adding before multiplying and dividing. See, adding is a whole separate step. Adding and subtracting, though, those both occur kind of in the same step from left to right using that order of operations. Okay? So basically we're going to go through and we're going to look for any parentheses, any exponents, and then we'll look for any multiplying and dividing. And we'll do that all left to right, and then we'll do the adding and subtracting last, and we'll do that from left to right. So, let's go through a couple examples of this. Okay, and by the way, I'm totally thrilled if you want to take a second and pause this and try to work through a couple of these. That doesn't hurt my feelings at all. If you want to work ahead because I'm going too slow, if I just won't, stop flapping my jaw, there you go. Just work ahead and verify that you get the same answer, and then that doesn't hurt my feelings at all. This is also one of the reasons why I'm wanting to do these recorded lessons, because we all learn at different paces. Somebody needs me to pause it, and somebody needs me to speed up. So there are your choices, right? Okay, so if I have 24 minus 12 divided by 3, I'm still, every time I'm doing this, I'm going down the list in my brain and going, okay, PEMDAS. Starting on the top, are there any parentheses? Are there any exponents? So there are no parentheses or exponents, so we're actually starting on step 3. That's going to be our first thing we look for. Is there any multiplying or dividing? Yes, there is. There is division. 24 minus 12 divided by 3, we need to do that division first. That means even though the subtraction comes first, we in the written equation, we are going to do division first in the mathematics. Okay, so this ends up becoming what? 24 minus 12 divided by 3. Then I go down to the fourth step and go, is there any adding and subtracting? Yes, there is. That's subtracting right there. We do last. 24 minus 4 is 20. I guarantee there's somebody in here right now that gave me 12 divided by 3 is 4. Okay? That's a common answer. I understand exactly what you're doing, but that's where we need to kind of think about our order of operations, go down this list, take care of the multiplying and dividing before the adding and subtracting. B. Look at PEMDAS. When I look at this question, I'm going to start at the top again. You're like, okay, I see adding and multiplying. Sweet, multiply first. No, there will be a way later on that we can multiply that 9 across things. We'll talk about that later. But what I see is that this 6 and 11 are stuck inside of parentheses. That grouping has to occur first. So basically what we do is we handle that group. Even though adding comes way later, that grouping tells me to do that first. That's what parentheses do, is they group things and they put that as a first operation. So that this ends up becoming 9 times 6 plus 11. So we do the parentheses first, and then, no exponents, but I see multiplying. Then we multiply. 9 times 17. You could multiply it like this. I also know that's the same thing as 17 times 9. Either way you get, I'm going to do it this way, 63. 9 and 6 is 15. Either way you get, 153. Expect to have to do that without a calculator. Okay. C. Look at PEMDAS again. Are there any parentheses? Are there any exponents? Is there any multiplying and dividing? Yes. That means that that multiplying and dividing must occur first. Before we get to the adding and subtracting, that adding and subtracting is at the end. That's the last thing we should do. So we should multiply first. 6 times 8 is 4. By the way, we're going to do this left to right. If there was a bunch of multiplying and dividing, we would handle it from left to right. What comes first is this multiplying. Then I have plus. We don't handle the addition yet, but I can now handle this multiplying. It's kind of separate from the 6 and the 8. So 5 times 2 would be 10. And then what do we do? Well, now that we've handled all the multiplying, now we're ready for the adding, subtracting. I color code that yellow here. And so the 48 plus 10 is going to be 58. Just work your way down PEMDAS. We did the multiplying first, and then we took care of the adding at the end. I'm going to show you some. These are going to get a little more complicated as we go and show you where this goes. This is important. This is not just like, we're not just doing math for the sake of doing math. The idea is that, all of this is the foundation of the mathematics that we use to start our car and turn on a light bulb. And so that's kind of important, that I know that every time I flip a switch to turn on my light bulb, that the mathematician used the same order of operations that we all have so that that light bulb works. I mean, this is not something we created. Mathematics is something we discover. So this is something that's all around us, and we are able to discover it, and the rules follow so that my car turns on and my light bulb works. Okay, enough of my soapbox. Let's keep going. Take a second, work through these, and that last one's just kind of more of a challenge, just to show you kind of the extent of order of operations. But let's go ahead and start on D now. I'm gonna keep writing this, because this is what I do in my head when I see a question like this. I start on the top and go, are there any parentheses? Yes, there are. That means whatever else is happening in there, we handle that parenthesis or that grouping first. So that 5 plus 6, even though it looks a heck of a lot like adding, and it is, it's grouped, so we handle that first. So this becomes 2 times 5 plus 6 is Now this is weird because we handled what was inside the parentheses, but there's still parentheses left, right? A lot of times, we can get rid of the parentheses, but this actually is just an important step to understand that what does the parentheses mean in this situation. When I have 2 parentheses 11, this means the same thing as 2 times 11. So I'm actually going to have multiplying. So I'm going to be kind of worried. I'm not just going to jump to multiplying. Look for any exponents. Like, not yet. Okay, then don't worry about it. That's not one of the steps we have to worry about. Now I look for any multiplying and dividing. Yes, there is. There is multiplying. How do I know which to do first? Well, these are separated, so it's kind of easier, but keep in mind, handle all the multiplying left to right. 2 times 11 plus 7 times 3. And then last but not least, I see adding in there, 22 plus 21, about 43. E, let's look at PEMDAS. Any parentheses this time? No grouping I need to worry about. E, is there any exponents? I'm running out of colors, so I'll just do that as blue this time, right? Yeah, that does not say 2, 3, it's 2 to the third. The most common mistake is you're like, okay, I can do exponents, and then we get to this point, and I'll have people go 6. Whoa, you got to remember what we just did at the beginning. What does 2 to the third mean, right? It means 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So 2 to the third is 8. What do I do now? Bring the rest of this down. What is left here? Well, I have a bunch of adding and subtracting. What do I do first? You're like, that doesn't matter. Yes, it does. See, when I have adding and subtracting, I have to look and do it from left to right. So make sure you keep that order right. I need to do the 9 plus 8 first is 17. 17 minus 5 is 12. In this situation, like I said, there are going to be times where you think, oh, I can reorder it, and that's fine. There are rules in mathematics that we can kind of reorder. We're going to go over those. But right now, we're just keeping the basic order of operations, and then we're going to extend on it. Let's kick it up a notch. Any parentheses? Not this time. Any exponents? Yes, sir. What do we have? Oh, there's that 2 to the third again. Not 6. 2 to the third, we saw earlier, became 8. What do I do with the rest of it? Bring it down. It is tempting to start handling this left side. You're going to get yourself in trouble, because after exponents comes what? Is there any multiplying or dividing? Yes, there is. You need to handle this first. What do I do first? I'll have a lot of people multiply first. They're like, yeah, but M comes before D. No, we already dealt with that. Multiplying and dividing are kind of one connected operation in this situation where we handle them both from left to right. Draw that little arrow either, on there or below it. What comes first this time is the multiplying. So if you did 8 divided by 12, first of all, this question is going to get a lot more complicated, but your light bulb is not turning on, right? Not figuratively, but the idea is that it doesn't turn on if we don't follow these same rules. 8 divided by 4 gives us 2. Am I done with the multiplying and dividing? You're like, man, I want to handle this stuff at the beginning. It's easy. Don't touch it. Finish the multiplying and dividing first. We still have multiplying and dividing. So we have 9 minus 6 plus 2 times 3 is. Now, what do I have left? I have adding and subtracting. How do I handle this? And as I go left to right, 9 minus 6 comes first, plus 6 And I understand that in this situation, there is another order that we could mess with that. But you just need to be careful because there are things that work sometimes and don't work other times. And so in mathematics, I don't want something that just works sometimes. I want it to work always. So if you're canceling out stuff, we'll talk about that later. But your basic idea of order of operations, you can just handle all the adding and subtracting left to right, handle all the multiplying left to right. That's where I find most people try to find exceptions to the rule, and they end up getting themselves in trouble. So be careful with that, please. I'm going to leave this up for a minute. You're going to maybe need to pause this, but these are different symbols. Different symbols that we need to be able to read. So this symbol is an equal sign. It literally means is equal to, right? Example, we can say that 0.5 is equal to 1/2. Means 0.5 is equal to 1/2. That is true. 1/2 is the same thing as 0.5. If I've got half of a dollar, I got 50 cents, right? This equal with a slash through it means is not equal to. For instance, 3 is not equal to 7. Okay, that's true. Once again, if you need to pause this, go ahead and pause it, but I'll go through the last line. I'm going to start scooting this down. This is a less than symbol. Literally, we say is less than whenever I see this symbol. If I saw this 6 is less than 10 is how we would read that. And that is true. 6 is less than 10. All right. Let me scoot that down. This is greater than. For instance, 10 is greater than 6. Write the words. Is less than or equal to. See, this line still means less than like it did before, right? But this line right here adds the or equal to. And that's going to matter as we talk about things. This says 4 is less than or equal to 8. I know it's not equal to 8, but it is less than, so that is still a true statement. I could say, 4 is less than or equal to 4. That would also be a true statement, as long as it's less than or equal. We'll keep talking about that. In fact, looks like I have one right here. Greater than or equal to. Is greater than or equal to. So 3 is greater than or equal to 3. Take a second and write that down. True or false? Read these with meaning and see if they're true or false. If they're true, put a T. False, put an F. This would be a good time if you need to pause it. Just take a second to write them down. Excuse me, and then work through. So is 15 less than 20? Hopefully I have somebody in here going, yeah, that is true. Is 12 greater than or equal to 12? You're like, well, it's not greater, but remember, for greater than or equal, or means either or can be true, and it's a true statement. Is 12 greater than 12? No, of course not. But is 12 greater than or equal to 12? Yeah, it's equal to 12, so this is still a true statement. Okay, anything true in here would be anything greater than or equal to 12, like 13 or 14 or 15, but it starts at 12 because of that or equal to. Is 15 less than or equal to 20 times 2? They're going to do a couple of these. You basically are going to need to kind of handle the math and go, well, 20 times 2 is 40. Then read the statement. Is 15 less than or equal to 40? Well, it's similar to the last one. We have to ask two questions. Is 15 less than 40? No. Is 15 or equal to, is 15 equal to 40? No. Then this is not a true statement. This is a false statement. Is 6/15 greater than or equal to 2/3? I don't know off the top of my head. How do you compare them when we have two fractions like this? Well, the easiest way, when I have a fraction, I think a part over whole, is we give them a common denominator. Basically what that does is it gives them the same size pieces so that we can compare them and see if they're similar, or if one's greater, or if one's less than. So I'm looking at two denominators, 15 and 3, and go, well, I know I could change that. Two options. I could take that 6 and 15 and try to divide it, or I could take that 2 and 3 and try to multiply it. I'm going to go the first way, and I'm going to multiply the top and the bottom by 5. Give them a common denominator of 15. So that makes this 6 over 15 is greater than or equal to 2 times 5, 10 over 15. Is that true? Well, they have the same denominator, means the pieces are the same. So now all we have to do is compare the parts. Is 6 greater than 10? If I've got, is 6 out of 15 more than 10 out of 15? And it is not. So this would be false. The other option, and this I don't recommend as much, this is going to be really my go-to, but I could have taken that 6 over 15 and divided the top and bottom and made that 2 over 5 is greater than or equal to 2 over 3. Well, this is interesting because these actually have the same numerator. So what I can do is I can look at the denominator and try to compare them. 2 over 5, 2 over 3. Well, what's more? You're like, well, 5's more, so this is true now. No, it's not. Because what does the denominator tell us is the number of parts it takes to make like a total of something. So this says, what would be more? If I took a pizza and I cut it into 5 pieces. I don't know if I can do that. I'll try. Here, just 1, 2, 3, 4, 5. So be kind with me here. Or if I take a pizza and I cut it into 3 pieces. What's more? 2 out of 5 or 2 out of 3? See, the smaller denominator actually gives us larger pieces. So this is still false. 2 out of 5 would not be bigger than 2 out of 3. If you have a larger denominator, that cuts the pieces into smaller pieces. So if I have the same number of pieces but they're smaller, anyway, like I said, that's why probably giving them a common denominator is going to be your go-to, the kind of the best way of handling that.